So that's what we got to do. All right, let's go. Okay, we're doing, well, hey, man, what's up? You want some muffins and some salad and some muffins and oranges? That's good, right?
That's perfect.
That's not pizza, at least. We're sick of that.
Yeah.
You know? Have some food, Liz. Okay. Guys, this section, this unit, we're going to look at multiple choice questions off of Unit 5, which is like where we started doing increasing, decreasing, concave up, concave down, inflection points, all that stuff, okay? This is how we're going to count these in a multiple choice. Guys, something about this unit in particular, so many of these questions where it's like 1 only, 2 only, 3 only, 1 and 2, 2 and 3, blah, blah, blah. Like, I hate those, but so many of them. Okay? Alright. Let's do this. Suppose the continuous function f is defined on the interval of 0 to 3. That's quite important. The derivative is defined by that.
No!
Which of the following is true of the graph of f? My friends, this is going to be a calculator question. I believe it has to be a calculator question. Okay? We grab our calculators. Grab your calculator, go into y equals. Let's go ahead and graph this, okay? Now look, I'm just going to put it on Desmos because then I don't have to keep going back and forth to my computer. But you guys go ahead and put it in. Go into your y equals. All right? Now let's type this bad boy in. E to the x sine x squared, whoa, minus 1. That's so fun. Grab it, see if you guys got that too. That's crazy. But I kind of fun. Okay. What? Is your calculator in radian mode?
No, it's in degrees of the channel because I was in radians and then that was bad.
Oh, it's physics degrees.
Not usually, but sometimes.
Yeah. Sure. Can you take the integral of that?
Yeah, just like plug it in math 9.
Yeah, I don't even know if I would do that. You could. Okay, guys. The fact that it says closed interval 0 to 3, could you guys change your window? What should you change on your window? On yours, you'll go to window, and what should we change? Yeah, x min and x max. We can go like 0 to 3. I mean, if you want to go like a little bit more so you can see it, that's like fine too. Ah, oh, it's so beautiful. I love it so much. Okay. Yeah? That is a really beautiful graph, I feel like. And so, okay, so what I would do on my paper. Guys, the way we find max and mins is we do a sine line graph from 0 to 3, and the sine line graph is of the derivative. And this is the derivative, right? So between 0 and 3, how many times does it cross? 1, 2, 3, because that one's past 3, right? So like on yours, you probably have it like, if I'm going 0 to 3, you probably have it like that. So it crosses 1, 2, 3 times. Now you guys, you don't even have to find the exact points, okay? Because this doesn't ask for exact points, all right? But look, if I were to do a test point over here, like 0.1 or something, that would be a negative value, right? A test point over here would be a positive value. A test point in here would be a negative value, and then a positive value, okay? So you're just looking at the graph of that. Now I'm going to come back over here, and I'm going to go. Now remember, it's on a closed interval. Well, that is too crazy. All right. Decreasing, increasing, decreasing, increasing. Does this have exactly one relative max? That's true. It's right there. Endpoints are never relative. They're absolute maximums, but they're not relative, okay? So, that's true. Does it have two relative mins?
Yes.
Yes, that is true. Does it have two inflection points? That I don't know yet.
But we know it's
But also it has to be one and two. So that is D.
Alright, but I still want to do a problem.
No.
Why do you like this? Alright.
You're supposed to do
No,
that.
you're the one who taught us to take short.
Oh, past the AP says.
Why is there only one relative mass?
I still want to do it. Okay, but let's say this was more like an open-ended question. Anyways, guys, can you describe for me, or does someone want to come touch up on the screen right there, describe for me where the inflection points are?
Like there.
There?
How many inflection points do you see?
And right here.
No! Not 3 inflection points. These are critical points. That's why the derivative equals 0. How many inflection points? Oh, good thing we went over that, Abby. Okay? Those are my inflection points. Slope positive, slope negative, slope positive. These points are inflection points.
Wait.
So does it have 2 inflection points?
Yeah, that's what I said.
Well, that should be 1, 2, and 3.
No. Yeah, they were like right there.
No, because that's like 0, negative 1. No, that's not inflection. 1, 2. Oh,
They're counting the one.
so sorry.
See, I was right.
Abby was
3.
right. I was wrong. My bad,
Good thing we
everybody.
went over that, Mitchell.
Exactly. 1, 2, 3 inflection points. It was on the top of my graph. I couldn't see it.
Well, I saw it with my brain.
Did you actually?
Yeah.
Ah. False.
That's why I was like, there's 3. I don't know what you're talking
Dang it,
about.
Abby. Oh, when Abby's smarter than me, it's very interesting. All right. Guys, at our professional development thing the other day, Mr. Thong taught one of the sessions. It was my favorite one. Him and Ms. Ward, I think, she's a science teacher. And they handed out this piece of paper that for us, like for teachers, and it was like, what makes you sad, like as a teacher? What makes you mad? And then it was like, what makes you, what was it? Sad, mad, and stressed. What makes you stressed? I filled up that whole page. I did.
I knew, made sure to name names.
And they were talking about it, and I was like, I have something to say. I get mad when they turn their work in on the last day. Okay.
You should have just named names. You should have just wrote down.
I know. Under all 3 categories, sad, mad, and stressed. All right.
Down.
Second derivative, guys. 0 to 4. Second derivative. Where is the second derivative equal to 0?
Right there.
1 and 3.
I was like, you can't say there, girl.
If I do a
She already
test
marked it. I
point
was like, right there.
at like 0.5, it's a positive value. If I do a test point at like 2, it's a positive value. And if I do a test point at like 3.5, it's a negative value. So this is concave up, up, down. Okay? Does the graph have points of inflection on 1 and 3?
No.
That's false. Because 1 is not a point of inflection, right? Because it doesn't change signs. That's not a point of inflection. Is it concave down 3 to 4? Yes. Now, you don't want to look
It's
at
concave down.
that. That is not why it's concave down.
Oh, it's
Even though that is concave down because it's poured water, it's not why. It's because the second derivative is negative. So even if it had been below the axis like that, it would still concave down.
That's the graph.
Because this is the graph of the second derivative, not the graph of the function. It says the graph?
No, it's
No, well it's saying this is the graph of G prime. It's just saying the graph of G is concave down. And it is true, I'm just saying it's not true because of that concavity. Okay, well, we were saying the same thing. Alright,
I thought you were trying to say something else.
I don't know what I'm trying to say, frankly.
Wait, so could it not be concave down the curve?
Yeah, I think what I'm saying is if this exact graph looked like this, that statement would still be true. Because it's not concave down because of the concavity, it's concave down because it's below the axis. Because it's negative, you know? Anyways, alright. If the derivative at 0 is 0, g is increasing at 2. What does that even mean?
I don't know.
Me neither. Okay, let's
Wait,
think.
okay.
Let's think. Hold on. Think.
Think.
Yes.
Okay, hold on.
Brain empty.
G increasing means G prime is positive, right?
So from 0 to
Shall we have to go out and look at those slopes?
Yeah, and this has.
Means. So like, one is a thing, and then two.
So if it's, okay, if G of 0 is 0, and we know it's concave up, if it's concave up, is it increasing at 2?
At 0, it's like a cutoff, so 0. What?
I don't know, I gotta think about this one for a minute. I don't know, because the place I'm getting these doesn't have the answers. Alright, Jacob, just go. Just kidding. What are you thinking, bud?
I want to take the integral of g prime prime, because then you're going to get g prime.
Yeah.
The area under the curve is going to be positive from 0 to 2.
You're right. Is this start plus accumulation? I think it might be. I thought so, Jacob. G prime of 0 plus the integral from 0 to 2 of g double prime equals g prime of 2. Yes? Is that start plus accumulation?
Yeah.
So I start at 0 and I add the integral from 0 to 2 and I get g prime of 2. Now, if g prime of 0 is 0, and what can you tell me about the area under the curve from here to here? It's positive. And 0 plus a positive would be a positive, which makes it increasing, so that's true. Good work, Jacob and Ms. Mitchell. Thank you, girlfriend. All right. Right?
Good work, so and Jacob.
Good work.
Jacob, tell me good job.
Good job.
Thank you, Jacob. You too. All right. Okay.
Jacob, tell me good job.
Jeez, Jacob, validate me, Jacob. All right. The graph of a function is shown to the right. So do you guys notice that, again, these are all like old AP questions. The first one gave me an equation for a derivative. The second one gave me a graph of a second derivative. Now it's giving me a graph of a regular function. So it's like all over the place. They might give you graphs,
So you always have to check.
equations, tables, and it might be for f, f prime, or f double prime. It's all that stuff. Got some. That would be good. Okay, let's look for false. All right. This is the graph of f, the actual graph of f. Now, I think that we learned on
Like,
our last
like
test in
that.
BC that that actually is a relative min.
Yeah, I was like, I think we know that.
Yeah, I hate that, but it's true. The definition of a relative min is it's the lowest point compared to all the points around it, and it is. So I hate it, but it is true. Okay? Okay. Guys, the limit as I approach A from the left and the limit as I approach A from the right, do those equal each other?
Yeah.
Surely? That's true. This says the limit does not equal the point. That's also true. So I just really hope that it's that one, but let's understand why. The derivative at A is less than 0, which means it means f is decreasing at 0. Oh no, at A, I mean, sorry.
But it's 0.
Hold on.
Well, there's only a.
Oh, not differentiable at A because it's A.
Wait, why is it Wait, why is it on? Oh, it's lower.
Yeah, so this is really like nitpicky kind of. Okay, that's a relative min. That's also a relative min.
Right, I get that, but it's in the middle of T. It's in the middle of like.
Oh, no, because it's not looking at that point or that point. It's actually looking at the point A, and A is lower than all the points around it because it's lower than the entire graph.
I don't think it matters.
That's all it's saying.
Oh, like
Unless
the
it's
colored one?
Yeah. So like, even like that where it's not a max or a min, that's still a relative min because it's below everything. Yeah, I don't like it, but it is what it is.
That makes it so open. It could be any.
If it's just a floating point, yes. Drink it.
The definition of a derivative is limit.
Is what?
The definition of a derivative is a limit, right?
Yeah.
So then how is it not differentiable if it's differentiable ever around?
Because there is
Oh, no, I got this one, guys, I got this.
Because there's technically no limit.
In order for something to be differentiable, it has to be continuous at that point. And I can prove that this is not continuous because left limit, right limit, and point don't equal each other because that's the definition of continuity. So in order to be differentiable, it has to be continuous. Okay, ready? Critical values means I take a derivative of this. Hey guys, I'm not sure yet if this is a calculator question or not. Let's take the derivative of it and then I'll tell you if it's a calculator question or not. Because I don't really know. What's the derivative of tan? 1 plus that squared, right?
And then
Times chain rule.
Wait, huh?
Yeah, this is most definitely a calculator question. I can't see how to do this right now.
But that's all over, that's all in the denominator, so if it's equal to 0.
Oh. Oh, yeah, you're right. Because it doesn't make us find it, it just says. Okay, hold on. Critical points are where the derivative equals 0 or the derivative is undefined, right? So guys, look, we gotta check where the top equals 0. We also have to check where the bottom equals 0, okay? Okay, let's think about top equals 0 first. Where does the top equal 0?
Not 0.
At 1. But yeah. Now, where does the bottom equal 0? Because those are also critical points. Yeah, because 1 plus something squared can never equal 0, right? 1 plus something squared, because then I'd be taking the square root of a negative, so never. So this has 1 critical point.
Wait a minute. Wait, I graphed it.
You graph arctan, or you graph the derivative of arctan? Okay, look. Okay, let's go back to here. Okay, arctan, and what was it? X squared.
No, it's 2x minus x squared.
2x minus x squared. Okay, but Raina, this is where the function hits 0. The function hits 0 twice, but critical points are where it changes from increasing to decreasing. Now, if on your calculator right now, go and type d dx of y1, where x equals x, you know what I'm talking about? And it'll graph the derivative and then you'll see it.
How do I do that again?
So you go math 8, and under your y2 do math 8, go d dx, y1, x equals x.
There's one of them that's kind of weird, but
Okay, so without actually knowing the derivative, but just looking at, like without actually finding it on your calculator, it would just cross once. Make sense?
Yeah.
Love it. Let's go. Hey, you guys can do this one. You guys want to do this? Okay, you're going to need to give me, and I'm going to eat some salad. You're going to need to give me a first derivative sine line graph, a second derivative sine line graph. This is no calculated question. Very standard AP question right here. Classic, baby.
I feel like I'm still dumb all the stuff on the top and do it.
I suck. Why did you toss this out? The best kind of salad is
Oh, we gotta practice it.
Is factoring involved?
Yes.
I don't remember how to do your factor method. I'm doing bottom up.
Oh, sweet.
What's
one more
stop? I don't know that one either. I never remember how to do it like that.
Oh, you can't factor that. Oh, come on.
It's 9 and 10, and then you do negative 1. Say let's work at it right now.
No, I know. One, it is factorable. I'm saying Abby can't factor.
I don't remember how to do your factor method. I can do it.
Also,
do it different
it's not my factor method. It's mathematics factor method.
I just used the one from the YouTube video. Show me again how to.
Yeah, wait.
All right.
Miss Mitchell, you make fun of me. I taught my 10-year-old brother how to do the box method for this thing.
Well, that's so cool. Okay, you guys ready? Here's how you do my factor method. Ready? Abby
Yeah.
You multiply it over.
multiplies to make 3x squared. 3x and x.
Your factoring method is incredible.
Thank you.
It's amazing. I just can never remember.
I think you're incredible. All right, Abby. I like you. Okay. 3 is 3 and 1, right?
Yeah.
Now, does it go 3 and 1?
Yes.
Okay, but then outside, inside has to equal 10, and 3 plus 3 does not equal 10. So then it probably goes 1, 3. Because then look, what's on the outside? And the inside? And I can make 10. Negative 9, negative 1.
I like my method better, Miss Mitchell.
That's fine. As long as you know your method is great.
It's the YouTube method. Do you want to know what you do? You multiply the 3 to it, and then you get 9. So then, and then you just do it the same
And then
way.
you divide it back out again.
Yeah.
That's bottoms up, man.
No, it's not hard.
No, it's not hard, but everybody forgets how to do it. Okay, so my critical points are 1/3 and 3, and it goes 0. Do you guys see why it's 1/3? Annabelle?
I just
No.
looked at it, Mitchell.
Annabelle, why is it 1/3?
Because if set equal to 0, then you add 1 and divide by 3.
Okay, good job.
I didn't know.
Alright, if I plug in 0, I get negative, negative. If I plug in 1, I get positive, negative. And if I plug in 4, I get positive, positive. Okay? Okay, second derivative, sine line graph. Well, it's between 1/3 and 3, but now we still gotta check the second derivative.
It's 5/3.
Oh, would you just? Alright.
Yes, this is one.
Could you just let me do it? It's the only joy of my life. Okay? If I set that equal to 0, I get 10/6, which is 5/3. It's just like right in between these bad boys.
So it is correct.
Anything to the left, if I plug in 0, gives me negative. Anything to the right gives me positive. And we're trying to go concave down, which is here. Whoa. So where is that overlap of decreasing and concave down?
1/3 and 5/3.
1/3 to 5/3.
It's C.
Incredible. It just feels good, doesn't it?
I love doing this.
I do love a sine line graph. It is true.
Miss do we have to memorize the equations for arc fans?
Heck yeah. Alright, you guys. This is a derivative. This derivative crosses the axis or touches the axis there, there, and there. And this derivative has horizontal tangents here, here, and here. Go write down 1, 2, 3 if you think they're true or not.
Okay. Oh, wait.
Oh, this is like
That's the graph of f prime. Huh?
C.
Hold up.
I'm just gonna throw it. It's going from
Positive to
positive.
But it's on here, negative. Oh, negative 2, not
Wait, what?
So it's B. Oh, yeah.
Yeah.
That was
This is negative. This is negative.
Yeah, you could also just say.
Wait. Wait.
Does a relative minimum work?
No. Wait, no, it's not. It might be because this is from. Oh, negative 2.
Minus slopes, positive slopes, minus slopes, positive slopes. Concave down, up, down, up.
Oh, and it was
I need that. Point of inflection at 1, true. C. Did you guys get that?
Yes.
Anybody have any questions about that one? Holy crap, this makes me so happy. Guys, I'm going to make a prediction before the AP test of who's going to pass and who's not. I bet it'll be 90%
You already bet
accurate.
like 50 bucks on not getting
I'll be 90%
5.
accurate.
Yeah, you she put 100.
I did not bet 100. There's no way. I don't even have $100.
A recording of you from.
Not 100.
Oh, I totally have a
Right
recording.
now, you'll get it.
It was 100.
I don't have $100.
No, I totally have a recording. Listen
Wait,
here.
but if she gets a 4, does that mean she gives you $100?
Did I really say 100?
That she get a 5. Not just that she passed, but she get a 5.
Hey, I mean, last year you haven't done that. I was getting like straight hundreds on all the tests. It's not that way this year. It's just
How
down.
do you feel now, Mitchell?
I don't know. We'll see. Yeah, chapter 9 feels Maddie. All right. Guys, the reason I picked this problem, I wanted to practice this one again because look, I have to go to the second derivative, but it's where you do a product rule and a factor out thing. And we tried that last week, and I think you got it, maybe. So where you do a product rule and then you factor something out and simplify it before you go again. Okay? Yeah? So can you guys try to do a second derivative of that real quick? Product rule, chain rule, and then simplify it before you go on.
Wait, hold on. How do you take a no chain roll?
Yep, product rule, chain rule.
Chain rule, that's just times 1. Upward is. Oh, yeah. And then you take
Annabelle, product rule, chain rule. Let's go, girl.
Should I distribute the two?
Wait, no, you have to do first.
This?
Oh, wait, you have that. Where'd you get there?
Wait.
Well, she said, I factor it out, but this is what we
Oh, wait, no, you can't take it. Okay, yeah. 2. No, but this times x minus 1.
I would not distribute, I would factor out.
First, it was hard as I think it was. Like, I looked at my chain roll. But then I'm like, oh yeah, chain roll.
I got the expression 7 minutes.
I was.
No, I did do something wrong.
I told you. I felt like I was something wrong.
That's the first one.
My derivative was even right though.
Hold on. What?
I got that.
Wait, what? Oh, wait, oh, no, that's
Okay, wait,
Yeah, I'm right.
I got it.
Oh, you cancel it?
Where's
Plus 2 minus 2, yeah.
So you do distribute it.
That's what I got for my first derivative.
Hold on. Let me distribute first.
Wait a minute. 3x squared plus
3
6x.
x.
You can do that too.
I got
3x
the top
plus 6x.
I
Okay,
messed
yeah.
up somewhere. I'm trying to figure out where, because I was close.
Why do I? Well, I got that, but I just didn't distribute it, and then I just took. Oh, she just took. Yeah. Should I have distributed it? Because the top.
All right, check it out.
What I did, I just didn't do
Just
it.
wanted you to factor it out.
Derivative first, second. You guys got that? And then first derivative second. We all get that?
Yes.
Because that's like to the first times 1, something like that. What I'm saying is instead of foiling that, you can, it will work, but instead of foiling that and foiling that, don't do that, that's blah, right?
I just.
Instead, factor out an x plus 2, right?
Yeah.
Okay, put it right here. When I take out 1x plus 2 from here, what's left? When I take out 1x plus 2, what's left? 1x plus 2, right? And when I take out an x plus 2 over here, what's left? X minus 1 times 2. Right?
Yes.
Because I took off one of those, there's 1 left, and I took off that, so that and that are left. Make sense? And then you just go in here and simplify that, which gave me x plus 2 and 2x minus 2, and the 2's canceled out. I got that. And then you could honestly do a product rule again, or at this point, I guess it's probably easy enough to do this. Right?
Oh, yeah.
So now second derivative,
6 plus 6.
3x squared plus 6. Second derivative plus 6x. You could either go product rule again, or if you multiply that out, because that's pretty easy, now it just becomes, 6x plus 6. So how many inflection points, or what are the inflection points?
X equals -1.
-1 only. Nice. Good? All right. When the question asks you to find the maximum value, it means,
Just the first derivative, right?
yeah, it means the absolute max. Sometimes they'll say absolute
You
max.
have to do the whole table.
Critical points, endpoints, table.
Wait, Mitch, was that?
Was what? -1. Woo! I just ate the spiciest onion. Alright.
Spicy.
Fire breathing. Guys, absolute, and if it just says the maximum value, it means like absolute, the highest value. If it gives you a closed interval, do you guys remember you do endpoints, critical points? Those are my endpoints. How do I find my critical points?
I'm doing something.
Derivative equals 0. Right? Do it. Go nuts.
Find your endpoints.
Endpoints are given. Those are right here.
Find your critical points.
Find my critical points.
Okay, wait, hold on. I'm gonna try the factoring strategy.
Okay, but not with this one.
What?
Because
Oh.
I already did factor. I'm good either way.
I can take out a 6. So you don't have to do that. That's a crazy method. Alright? See, but that's a GCF. You don't have to do that.
So it's 2 minus 1. So the only one is 1.
Correct.
And then you have to plug them into the original.
Yeah.
0, 0, 0 plus 4.
You guys are learning. It makes me so smart. Makes me so happy.
Thank you.
I don't know.
So I did something right, but I don't know how to go from there.
Okay, did you find your critical points?
Yeah.
Guys, when I go to do candidates tests, look, I always put my endpoints like that. so that it reminds me that I can only put the critical point in between 1 and I don't use negative 2 because it's not in between. Okay? Now what do we do with the 1, 0, 1, and 2?
Like, then we try to survive.
Like in the original.
The answer is A.
4.
Wait, Mitch, does that?
What?
No, isn't it? Oh.
Well, actually.
10, 28, divided by over 4, 8.
Yay.
The maximum value is 8.
Oh.
You're so skilled.
Jacob made a mistake, everyone. Quick, look at him. Quick, he's erasing. Jacob made a mistake. Jacob? Jacob, did you try to make a sign line graph?
What? No, I forgot to plug it back in.
Jacob! Unreal. Unreal how good you are. No. Do you understand why the answer is 8?
Yes. We were just adding wrong.
That's
We
good.
got 0 first.
Wait, you got negative 3 for the 1.
28 minus 24 was 8.
12,
0.
2 plus 3.
Then we still have to add.
That's 5, right? Minus 12. That's negative 7.
6. Got it.
Woo! Alright.
I know what I'm doing.
Hey guys, this is another fun one. Let's speed run this.
Oh, that's fun.
Let's speed run this. Ooh, that's the worst. Actually, let's do it together. Okay. This one is not what I was thinking.
I did the derivative. That was bad.
Yeah, but derivative equals 0.
And then you just.
Okay, so it's 6x to 1/2 minus 6x. Now, hang on.
And then you just take out a 6x to the 1/2, and then you're left with 1/2 x. Or
Okay, no, but you're on the right track. I believe we can do this, though. We can factor out a 6
oh yay!
and a square root x.
Oh my gosh, I actually did that.
Now, hang on.
Wait.
When we're factoring, we're dividing out. So when I factor out a 6, and then what do I get when I
X to the
factor out a
1/2.
square root x out of an x?
X to the 1/2.
Yeah.
Oh my gosh.
Maddie, that was kind of smart.
I know. It's the first time I'm
Amazing.
here.
Hey, you're gonna get a 5 in those. You're gonna get a 5.
All right, everyone, let's not go crazy. All right.
We're not reaching for the impossible right now. Okay.
Okay. So 6 root x is 0. 1 minus root x is 0. Gosh darn. Oh yeah, I do need that. So x is 0. Right? And what about over here? What does x equal?
Yeah.
1. Okay. Sign line graph. Okay, so hold on.
Subtract 1 over -1 divided by, and I'm so lost.
Oh,
How did you get 1 from that second equation?
negative root x equals
Because
negative
you
1.
get
Square root
x
x
to
is
the-
1. Square both sides, x is 1.
So then you just
I
one
just couldn't
square.
think through that.
Okay. All right. Guess what, guys? We're not going to plug in anything less than 0. Because anything less than 0 doesn't give us imaginary numbers. Right?
Yeah.
Okay, so let's plug in a half.
Yeah, and I was like,
Guys, square root of a half is positive.
the whole story.
1 minus square root of a half is positive.
Sorry. Talking about
Okay, and then I'm going to plug in 4. Square root of 4 is 2. 6 times 2 is positive. 1 minus 2 is negative.
I'm not loading.
What's 2 to the half? Wait, never mind.
Wait, why is it
Just
cut off at zero?
a second.
Yeah, why is it cut off at 0?
Because what happens if I try to plug in a negative number to this factored out part?
I don't like that.
If you do a square root
Yeah,
of
square root
it,
of negative.
Yeah, makes sense. Cool.
Okay, so it's increasing 0 to 1, and all those are between 0 and 1, so that's crappy. So now we got to do our second derivative. Okay.
I say exact 0. I'm just kidding.
No, we're not gonna guess. This one's easy. How do I derivative this? Bring that down. What's half of 6?
3.
3x to the negative 1/2 minus 6. That's the second derivative, yes?
Yes.
Tell me another way to write that. 3 over.
Yeah, 3 over
Square
square root
x.
of x. Okay, I was like, I stopped myself. I was
Like,
like,
where that
stop.
equals
I
0.
was like, what am I saying?
Oh, this is fun because I love when we get to here and then you guys forget how to algebra.
Wait.
Wait.
It's
1/4. It's -4. 4. I'm putting it -4.
I think you might be right, Rena.
I did it. I wrote it out.
Add 6
Then you
Yeah.
times by.
Oh, it's over.
times by square root of x.
I know what I'm doing.
Then divide by 6.
Divide by 6
And then you square it, which is a quarter.
squared. Oh, that's exciting.
Miss Mitchell,
What?
do you want to know what I did out of them?
Oh.
I'm scared.
I'll show you my math. I have a negative x, but it works for you.
Oh, rip. Oh, jeez Louise. That's not good. Okay, now I'm testing into here, you guys. A very, 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 very tiny number, like 1/16 maybe. The square root of 1/16 is 1/4, and 3 divided by 1/4 is 12. So that's positive negative.
Why not 0?
Because I can't divide by 0, bro.
So it's from 1/4 to 1.
Because if I do, I can't divide by 0.
No. So it's
Are you talking about plugging in 0 right there?
Yeah.
It'll still work, but no, it won't actually.
It won't because I got a negative number.
Right. And then if I plug in, let's say 1, 3 minus 6 is negative. So
I'm just stupid.
I don't like that.
where is it concave down? Above 1/4. So where do those intersect?
What's the square root?
From here, it's
Between 1/4 and 1.
down.
I kind of like those
Oh,
questions.
I thought we were looking for it.
That's decent, right? How do you guys feel about that?
Wait,
Feel
I'm
good? I
sorry.
feel good. We feel good?
What?
No? Let's get you to the point where you can do it.
I
Like.
just got lost. How?
What? I hear everything. I can hear all.
It's terrifying. I'm glad I was you are.
Oh, yeah.
It's just like a teacher thing. I know. It's fine. It just freaks you guys out when I respond. Alright, you ready?
How do you math? That's my. What? How do you algebra?
Don't worry,
Is the answer C?
Okay, ready?
Miss Mitchell, I need help on solving 3 over
Oh, that goes
square
with
root of
this.
x equals 2.
Multiply both sides of the square root of x, or cross multiply.
Wait, did we just get one?
I don't think so. Oh, did we? No.
Okay.
I just can't do
I mean,
it.
we have another.
Aren't you doing this question right here?
Oh, mine is really hard.
6, not 2.
Oh,
It's the opposite.
thank
Yeah.
you. I messed up in myself. Thank you.
Wait, did we? I got it. Did we skip?
Yeah, we skipped one.
No. What did we skip?
I skipped the.
Oh, the e to the x one. No, we should do that.
Okay. Bring it.
So we have a break.
After this problem. Guys, this is another practice of taking 2 derivatives, factoring out an e. I swear this is very similar to something we did the other day. Alright. Derivative of the first second plus first derivative of the second. Okay?
Wait, inflection is that the first derivative or the second?
Second. Now guys, from here, before I take another derivative, factor out the e to the x. Woo. And what's on the inside?
X squared plus 2x plus 1.
Yeah, and I'm going to just reorder it, that's fine. And now I do the second derivative, and it's one product rule. Instead of here, it was like double product rule on both of them, right? Okay, so now I'm going to do another product rule. Derivative of the first times the second plus first derivative of the second. And then what are you going to do? Factor out an e to the x again. Now I have x squared plus 4x plus 3. Ooh, I love this question. I love it.
Oh, that's really nice.
Yeah, I'll marry this question. Alright. Ready?
And then
When I take it back, don't come back to the
No.
e to the ln. No,
E to the-
that's down. It's
What did I tell you
Never equals
guys
zero. Never equals zero.
about e to the x equals 0?
It never happens.
Never does. Very good.
is it because it's down
and
as
the
the
around.
Yep, because look at that's the graph of e to the x. Also because you can't make the ln of 0.
yeah.
Okay, so what are my inflection points?
Negative
And 3,
one.
-1. There are 2.
Yay! That was really
We need a break?
Yes.
Yes.
Let's take a break. 5 minutes break. Right, I represent Maddie.
Me, I'm there.
Raina, Gabby Johnson, Ryan.
Oh, it's right here.
Okay. Rock. Lydia.
How come you gotta put my last one?
I don't know, don't I have more than one Chris? Maybe, I don't know.
I don't think so.
You're Chris K, not Chris.
You're right. You're right. I am Chris K.
Andrew,
Some people call me Chris K.
Henry,
And my one
Albie, F,
Just take the one.
and Jada. Alright. Now. Oh, and Jacob! I almost looked you on my list, Jacob. That would have been tragedy upon tragedy. Jacob doesn't freaking need
She's like, yeah.
I bet buzzing his head up pretty soon.
I had every single bowling but one.
I'm just so good at my sports. I don't know what they're probably already know this is my parents.
Probably coming your way out.
You want me to ask?
You probably think it's like the last thing I know. They're gonna go up to him and I'll be like, no.
No, you are smart always.
Just thinking about who I should ask to play. Why did you text me? Why did you text me? You just text me what it was.
Yesterday I had to eat a pizza. It was awful.
About what?
Or it's okay. You want to just like
No pressure, Abby, no pressure.
Oh my god.
Yeah, Jacob agrees with me.
I do agree with her.
was the smartest one in our class.
Yeah, totally. I actually want to.
Oh, gee. There was never one time.
I told my counselor. I like how you said
Everyone's getting annoyed.
Wait, so do I have to sign up for every month? Am I good? Yeah, let me see. Who's the other one, right? I think Miranda said that if she like had a choice, that's who she was gonna choose.
I think so, yeah.
It'll be fun. That's all I know.
Let me see if you want to do this with both of us. I'll do it, but if not,
That would be fun because you can each be on one of the teams.
but it also could be very, very.
It could be a little stressful. I would say though, just make sure that you can go to the Dixie training in the summer. 'Cause that's,
I should be able to, as long as it doesn't. What week is this? Okay, I think that should be good.
I almost failed art.
because that is fun. If you miss that, you'll
Yeah, so I'm not.
I almost did.
Yeah, so we're gonna do like that.
Dixie was the lowest.
If I did.
Annabelle, is anyone ready?
Nope, that's so nice. So I'm like not stressed at all. I'm like, do I even need to show up to my interview? Just kidding.
Yes, Annabelle!
I
I can still not accept you.
Can I be vice president? Can I be runner-up vice president if she doesn't make it? And then JP can be
Oh, you do
historian.
not want to play this game with me this week. It's an automatic L for you.
Alright.
She doesn't want me on student council anymore. She's done.
I'm done with Annabelle.
Yeah, for real, me too.
It's okay, Annabelle. I think she's done with me too. She sees me too much.
Freaking so much. I know.
You were like, I'm done. And I was like, ooh, Rick.
What's funny is I see Miranda before and how many times with them now.
Yeah,
Everyone.
So technically, you should love me as much as you love Serena.
I made that flyer, could you tell? Yes. That's so sad. I was like, this is stupid. It was a photo, and I swear the teacher said, hey, at least it was okay. At least I got twos. It's like the face I made. I totally got that, right? I was like, oh yeah, I should have done something. I did really halfway through the week. Like, also, like yesterday when
Why does they like this?
Wow.
And make mad.
yeah, you
Are you serious?
Yep.
I did it.
You normally don't know what you're gonna ask me.
But then
By the way. In food.
as she should.
And I was like,
It's the top photo that's what's on. Why did we go? That's so fun.
Usually
It was 3 to 7.
15 words.
I see this often 16 letters. I remember that right now. I was like, it was 4th grade, but it was so hard.
are you serious?
The worst thing is that that looks kind of like me. You told me that. Yeah, but it's the orange finger.
I keep getting those stupid things.
I don't know what I'm doing. Oh no, what is
It's
that?
so funny. Does it actually kind of look like his face?
Miss Mitchell, what if it was just like a sort of yes, sort of no to a red and golden, where it's like, if like activity-wise you need help, but like, we're like, you
now
know?
make these accusations.
I think so.
Okay.
Hype it up. That's what we're going to do, no?
Sure.
What did I say?
Are you crazy, Captain?
Oh,
Wait, but I'm
great.
doing that during the game.
Are you kidding me?
We'll see. We'll see.
It's gonna bother me all day.
We need to do
Yeah. Tell me next year it's gonna be crazy. But it's kind of rough though. I'm playing three sports all during the season, but I'll be there at all the games.
You'll be there for volleyball and football.
Yeah.
You gotta be there. No way.
And then in spring and fall I'll be there for soccer.
Yeah. Alright, you guys, let's do this.
Basketball, volleyball, so.
Okay, here we go. Graph of G. This is the graph of G. This is not a derivative, it's actually the graph.
I don't really know.
Where is G prime 0 and G double prime 0?
Prime is 0.
I'm sorry.
Oh, that's G double prime is 0 at E and B.
Yeah, I would definitely say B.
B and E.
What does G prime 0 mean?
It means the slope is D.
Critical point slope is 0.
So B and F.
B.
And D.
Okay, you guys ready?
I'm sorry.
Come on now. Okay, G prime is 0 at B, D, and E. Now, what does it mean for the second derivative to be 0?
It's switching between concave up and
Switches between concave up and concave down.
so at like -1 and like 2.5.
Well, no, what about D?
So, hold on.
I'd rather B.
That's concave up to concave up, so it's definitely not that, right?
I think it's to D.
It can't be B.
No, I don't think it's
It has to be.
It has to be.
And E to E.
Oh,
So the
yeah,
answer is
that's-
B.
yeah.
You are so right.
Wait, what does G prime of X equals 0 mean again?
It means that there's a horizontal tangent there.
Oh.
So if it's 0, it's a horizontal tangent.
Oh, yeah.
Okay.
I get bonus points on this one.
Guys, I really like question 12, but it's a little bit tricky.
Oh well. Let's do it.
You gotta be kind of on your game for this one.
No, I'm kind of a genius.
I'm always on my game.
You might say.
Fair enough. All
I'm
right.
never on my game.
Agreed.
Okay, first of all, the fact that the point 0, 1, even without telling me anything about it, the fact that the point 0, 1 is on the graph means what?
Something important.
What can that help me do? Using this. That
I'll give
means
you one college.
when I plug in 0, I should get 1, right? Okay, so look.
Okay.
0 to the 4th plus a times 0 squared plus b has to be 1.
So you know it's D then.
All right, I'm still going to do the whole problem, Jacob.
That's a good problem.
So b is 1. But we're still going to keep going because what if it was... All right. Jacob?
It's literally shortcuts. Like it's
I know,
AP test.
and that's fine. But what if that wasn't there? And what if it was on a desk? So what do I do? Okay, ready?
Okay.
Because this is fun, guys. Come on now.
I don't
Come on
like
now.
that, but okay. I don't
All right.
find this one of the
The fact that there is a relative max at that point, what does that tell me? No, because we've had questions like this. So I want to make sure you guys kind of. How do I find relative maxes? Jacob's leaving because he
Oh
didn't like
yeah.
it. Bye, Jacob!
Vertical.
Do that. Take a first back to the road. Relative max means there's a critical point. Okay? Which means, you guys, that what will the derivative at 0 be? 0.
Wait, what?
Because that's when the slope is 0. Critical point, whoops. So I don't use that 1 anymore, that's for f, but the derivative at 0. Now what's the derivative of this? 4x third, 2ax, that goes away. So 4 times 0 to the third plus 2 times a times 0 equals 0. Hey, that told us nothing. Because that said 0 plus 0 equals 0. Lame. All right. But now we got to go to the second derivative. Okay? If there's an inflection point with x is 1, what does that mean? If I plug in 1 in the second derivative, I should get 0. Because that's where we get inflection point. Second derivative is 12x squared plus 2a. So the second derivative at 1, this time it's at 1, not at 0, it's at 1, is 12 times 1 squared plus 2a, and that equals 0 because that's where inflection points equal 0. 12 plus 2a is 0, so 2a is negative 12, so a is
6.
negative 6. Let's go.
And that's what I meant.
And now, and only now, can we pick?
No, we could have done that way longer.
You're right.
And now
And
it's-
honestly, on a multiple choice test, be smart, but I still want to go over these. Like, I would have done that.
That was an AP question?
Yeah. These all are old AP questions. From the tests that they've released. They don't release the multiple choice, they release the FRQs all the time. They only release the multiple choice every like 5 years. Alright.
Because they reuse questions? Or?
That's right. Yeah, they reuse them. Okay, ready?
Yeah.
Velocity. You guys see velocity time graph. Okay. When is anything at its minimum? How do I minimize something? I take the derivative of it, right? The derivative equals 0, and I do a sine line graph. Okay. When I take the derivative velocity, this is a portrait hole.
I don't like that.
Nah, nobody likes
The
it.
top times
It's
the
not bottom.
bottom
Minus
the top
top.
times the derivative of the
Derivative of the top bottom.
Yeah.
Top
You
derivative
don't
of the
even need to
bottom.
put the 1 there. That bugs me. Can I factor in e to the
Wow. Yeah. We can factor out e to the t, and then it's t minus 1 over t squared. That's fine. Okay.
And then don't you just have the top equal to 0?
Now, when the top equals 0,
We should do the bottom equals 0, Miss Mitchell, just for fun.
That's
well,
yeah,
when the bottom equals 0, it's either a critical point or an asymptote, but it kind of depends on what's happening over here.
Isn't it say t is bigger than 0? So I think
Ah, so we don't even have to worry about that.
yeah.
So they're saying we don't have to worry about that because it was going to be an asymptote right there anyways. That's fine. Okay, when I'm doing test points, you guys, hey, I want you to be smart about these sine line graphs, okay? No matter what I square, what's it always going to be? Positive. E to the anything, what's it always going to be? Positive. So I only have to really test it here. If I test in a half, it's negative, and if I test in 2, it's positive. What value does it attain its minimum? 1.
That's so nice.
Okay? At what value of t? Hey guys, real quick question. If I said, what is the minimum value of velocity? If I said, what is the minimum value, what would it be?
0.
What is the minimum value? You plug in the 1 and you would get, yeah. Okay? But it's saying at what value, so what t value.
I just want to say 0 and then.
Guys, I left so many of these on here because there's just so dang many of them. Alright, let's take a look.
I love these.
Graph of a derivative, which of the following is true? Okay, first derivative, negative 2,
Not
2,
1, right?
above, below.
1 is wrong. She's doing the local maximum.
So this is my sine line graph for my first derivative. Positive, positive, negative. So it's increasing, decreasing. So is it decreasing at 0? No, that's false.
So 2 has to.
Does it have a local max at 2? That's true.
Wait, that's so dumb.
Because it's changing from
Why?
It's negative. It's changing from negative.
We've done this 100 times. Why are you mad now? Why were you mad when we did this before?
Yeah, but it's so
Oh,
confusing
that's right,
because it's
It's a graph of the derivative.
that's why I messed up.
Aubrey, are they going to mess with you on the AP test? Yes, that is their literal job.
D.
Second derivative, it's 0 at
Right, but on the actual.
negative and 0. Negative slopes, positive slopes, negative slopes. Concave, down, up, down. Is it concave up at negative 1?
yes.
True. So which is true? 2 and 3. I like those. I do. I think we're getting like so good at that, right? Is it just me? I don't know.
It's just
Okay, are you getting good at it too, Jada? What do you think?
By tomorrow, probably not. But today, yes.
Yes, let's go. I can't ask for the world, man. All right. Hey, now we got to shift our thinking a little bit because this is the graph of the second derivative. Dun, dun, dun. This is long as true. Okay, guys, I'm going to start with a sine line graph. A4 to 4 for a second derivative, and the second derivative equals 0 at -1 and 3. And it's above the axis, below the axis, above the axis. So we're going concave up, down, up. Okay? Is there an inflection point at -1?
Yes.
True. Is it concave down -1 to 3?
Yes.
True. God. Now I have to look at 3 because it's either 1 and 2 or 1, 2, and 3. All right, fine. Is the graph of the derivative increasing at 1?
It's looking at slopes because the derivative of the derivative is positive.
Well, but the derivative of it is the tangent line, right? Which would be a straight line.
F
Yeah.
increasing, so negative F.
Well, here's what I'm thinking of it. Hold on. F prime is increasing means F double prime is what?
0.
Positive.
What?
Yes, because it's like the
Because
integral,
where
right?
F is increasing, F prime is positive. So F prime is increasing, F double prime is positive. So is this positive at 1? No. Negative.
Wait. So, you know how like the integral is like the area between the curves, right? So if you just like look at that area and see that area is negative.
Yeah, negative area.
Yeah, but like that
So
also
it's
works.
decreasing. Yeah, that works too.
Okay.
4 chisel. All right. Guys, I want you to do whatever, 2 derivatives of that with a quotient rule. We so got this. Look, I'm going to do mine, you do yours, so don't watch me. Derivative top, bottom, minus. Derivative bottom, top, over bottom, square. Oh my gosh, this simplifies so much.
I just did e to the 2x. I hope that's right.
It is.
You're really small.
That's really nice. What multiplies 20?
Cancel so much.
Can I just do x plus 1
Wait.
squared?
Oh, wait. Wait. Wait.
Because it's x plus 1 squared, right?
Whoa.
I forgot you could
What did
You didn't do derivative of the top. You didn't do derivative of the top. It should be 2x.
Yeah, it should be 2x.
Not x squared.
Same difference.
No, it's not.
Rats.
I was like, hold on. That is not right.
I think I would have eventually seen that.
Instead of
maybe.
factoring at the top, you just cancel out a to the x and all three.
Sorry. That's all. But it's still nice. It's just.
Okay, I can still cancel one of those and one of those.
Just kidding.
It's not great. Dang it, my way was so much better.
Yeah, but it was wrong.
Yeah, but still, it was better.
No.
Okay, there we go. Do we get that for first derivative?
Yes.
The bottom never equals 0. When does the top equal 0? My friends, I'm going to factor a negative out of that.
Yeah, I was.
And then that, what is x squared minus 2x plus 1 factor to?
X
That
plus
would be
x. Wait, no. X minus no.
That would be
X minus x plus 1.
Minus 1 minus 1.
2 -1. That's what I'm.
So it's x minus 1 squared.
Dang it!
Yes.
I got x plus 1 squared.
Now,
Annoying.
it's x minus 1 squared. Now, if I plug in, like, let's say 0. Okay, I did a bunch of stuff here, guys. That's the top, that's the bottom, okay? If I plug in 0, I get negative 1 squared, which is a positive, times a negative, which is a negative. That's always positive. If I plug in 2, 2 minus 1 squared is a positive times a negative is a negative.
Right, that's all.
So guys, it is decreasing everywhere.
So we just have to find where it's concave down.
Yeah, so that's lame-o.
Wait, Didi, is something squared? I swear you said that there's something when it comes to limits if it's squared.
What I was saying was with your sine line graph, if it's squared, around that point, it will either be positive, positive, or negative, negative, or won't change that.
Well, no, it's not that. It's not the square thing. It's like a limit thing. There's like a limit thing where it's like if something's squared, it's like not a four. But I swear there's something where it's squared.
I don't know. Alright. I don't know. We have to do another derivative.
Yep.
Alright, let's go. Are you ready? Derivative of the top, bottom, minus top, derivative bottom over bottom, squared. I can cancel out the e to the x again, so this would be positive x squared, negative 2x negative is going to be minus 4x. Negative 2 plus 1. Huh?
Did you not distribute the negative?
No, I just did.
Plus 3.
That's actually not that bad.
No, it's not chilling. Okay, we're top of 0.
We're just like simplifying this stuff for days, guys. And it's not bad. So that's minus 3, minus 1.
Wait.
So 1 and 3.
I cannot. Once I get started, I just can't. Just can't stop.
So plug it to 0.
Positive
That's
3.
positive.
I don't want to do the math. I'm just gonna let you do it.
Can't stop. That's not bad. Alright.
Wait, does that say x plus or x minus?
So from 1 to 3. 1 to 3.
1.
C.
That was rough.
For you.
Hey! Was it fine for you?
Yeah.
Alright, sorry.
I'm so correcting you. I was like, that is not
I'm
right.
going.
So you plug into 2.
Alright, ready?
Wait, did you really even have to do all that work if you already
Wait,
got
why do I
the
have an
point?
point right here? No, it's because the bottom.
Oh, because it's the down thing.
That's like.
Or I,
Well,
when you enter out of parentheses, you have to distribute.
Alright guys, so
That's why, and this is going to be minus.
what they're going to touch you on both multiple choice and FRQs
Oh,
is looking at a graph and analyzing it, looking at an equation, and looking at a table. This is kind of our first chance to look at a table and analyze, okay? F is continuous and differentiable. What F? Okay, guys. Let me help you break down this question. You ready? Okay. So as I read, before I do anything, I read through my answers. It's usually I take a multiple choice test. Okay. It's asking me about points of inflection. Oh, good. Isaac's there. Zeros.
Why did that sound like that?
Oh, good. Isaac's here.
You were never that high.
I was thinking 37 minutes. 27 minutes.
You should put a new one too.
Nicely, Isaac. Isaac. God.
Math or
Oh, so bad.
Wow.
You need to lift more weight.
How's ballroom dance going, athlete? You? All right. Okay.
Yes, you should also come sit over here. You should throw me one
Nice. He's a dancer. He can't do this. Okay.
How does that say?
Yeah, he wrestles and he does.
I need to win. He doesn't know shoes.
I would like to slam Isaac.
Oh yeah.
Yeah, he's doing it. Exactly.
Okay, that's fair.
I mean, none of those are
Hey,
going shorts, but he should.
Isaac, since you're here, you're gonna help me with this question. You ready?
Okay.
Okay. Just looking at this table.
I don't remember.
Okay, hold on. No, you don't need no calculus for this, for us. He's fine. Isaac, do you know what a zero is? No, like a zero when the graph of if a graph has a zero, what does that mean?
Oh, it's a 0 off 1.
Crosses the intersection.
Yeah, it's got a cross zeros?
Yes.
Isaac.
Isaac.
Where?
Between 1 and 3?
No.
No.
Put the, it's
Listen, my y values, can I go from 3 to 1 without crossing the axis?
Oh, then 4 and 7.
Can I go from 1 to 5?
Yes.
But I can't go 5 to -2, I would have to cross the axis. So there's at least 1. There's a theorem that tells us that. Anybody know what that theorem's called? Close, but no.
Intermediate value.
Intermediate value. You have to throw words in. Alright.
What's it?
Okay, relative maxes and mins.
Nothing else. It's not used for anything else.
Wait, does that mean that B is
If I
incorrect?
connect it down to
Just
2
cross it off?
-2, I have to cross.
Yeah, it does not have to have 2 zeros.
Like, okay, it line all the way across page.
And otherwise it doesn't
That
count.
one, that
Yeah.
one.
Alright.
Have to cross that, that's all.
That's so stupid.
Yay, exactly.
I'm so excited about that.
Wow, you're gonna walk away.
You want some breakfast?
Finally, that's why I asked for that. Wait, how do we do that again? Changing.
How to make it more aerodynamic.
Good job, Isaac, we're proud of you. You're gonna like pick it up?
No, we're gonna bring more.
That's just like,
And little like, drive like this, like. Did you hear it? Wasn't Zach just here? Like, put your mouth on the paper. I can't talk.
Henry, what are you thinking about this question?
yeah, Henry, what do you think?
Just kidding.
You're probably thinking Abby.
I'm not looking at the graph. I don't know what's right.
I think the keyword is done.
Right, we'll get it back
I think you're right.
I can do that. I can do that.
I'm a pro at keeping phones away from me. You should ask me. She still doesn't know that that's a real phone.
Whoa, why do I have that picture? Okay, we're not.
Yeah. Okay, guys, listen. Let's go. You guys-
Like my sketch so far for French club.
If I plot these points, does it?
Abby.
Okay, look.
It's down. I've been trying to open this.
If I connect them, it has to have at least one relative min, doesn't it?
Yep.
It has to have at least one relative max.
You're just saying.
Oh, so that one.
It doesn't say it's a polynomial, right? So theoretically, couldn't it be 3 line segments? In which case it would have no points in the question.
Wait.
What do you think, Henry? Because we don't know, okay, we know that it's differentiable though, which means that it has to be curvy. You're right, Henry. Alright. So, if it's differentiable, there's no sharp corner. So there has to be at least one point of inflection.
Yeah. For a second I couldn't remember what I said.
So it can't have two, it doesn't have to have 2 points of inflection.
What is a maximum?
It's right there.
Maximum.
Yeah, it's just like a fancy.
I think it's gonna be D. Henry, what do you think, D?
But just.
I'm going with D.
Yeah.
I think it's D. Yes.
Because 1 point of inflection right there.
Why do you circle that?
Why not?
Because it looks uncomfy.
Because you can see it when you
It does look really uncomfy.
Because it doesn't have to have 2 relative maxes. It just goes.
I
It
don't
doesn't
care.
have to, right?
Actually,
That is a tricky question, my
when
friend.
you flip through your packet, you can't see the circle.
Yes, I can.
No, you
I am
can't.
not lying. I so can. And you don't need to flip through it that fast.
Guys, I kept this question on here because I thought it was interesting because it was cosine of sine. Hey, guys, Isaac! So happy you're here. Isaac, if I plug in 0, what is this equal? Nope.
1.
Are you guessing?
I was the first time.
Are you guessing now?
I mean, no, I wasn't the first time. I am now.
Stole my spot.
Yeah, but he was just guessing.
I took the sign of 0.
Okay, so guys, let's go. If the derivative at 0 is 1, which is a positive number, what does that tell me about the function?
It's
G is increasing. Yes? Okay, cool. So that's true. Now, I need to learn about the second concavity, which means I need to do a second derivative. Okay? Can we do a second derivative, guys? What rule? Chain rule. Derivative of cosine is negative sine of sine times cosine.
Could you like find the integral of that like at the same time? Because I try to think about it like when it.
There's no integral.
That's what I thought.
There's the end like you said.
It wouldn't make sense.
Okay, so the sine of 0
It's still 0, isn't it?
is 0 times 1, which is 0.
Yeah.
Yeah, hold on, guys.
So it's not concave down.
So it's not concave down. Does it attain a relative max? What do you think? In order to be a max, it has to have a horizontal tangent, which means the slope has to be 0. The slope is 1.
So
Yeah. All right, you guys, let's get through a couple more. Ready?
What was the answer to 18? Isaac was excited about
1 only.
Thank you.
Did you get it right?
Yeah.
Really?
No, I didn't get it right.
Is it because Isaac got here?
Yeah.
Isaac, come sit up here. You're distracted.
Probably not yet.
Isaac, when you come and you distract people, I'm going to put negative points on your grade. Instead of getting extra
As long
points.
as I get negative and then just
-1.
Alright.
I'm listening to you all year.
I sure hope so. Guys, listen up. Have we done enough of these yet? Can you guys do number 19 by yourself? I mean, like a while ago. It's 8. Everybody's distracted today.
All the numbers are weird, so it's 19 over 8.
Wait, am I off?
Yeah.
Oh no, it's because your number's down at the bottom. Yeah. Sorry. Okay. F is increasing.
okay, I think I got my answer.
Positive, so it is.
Inflection. Let me get up with it.
Oh, wait, no. Wait.
Ferrari, let's freaking go.
Let me still do this. Give me a second.
I'm letting you do it. I'm not doing anything.
It just makes so much sense to me now. Now that we like the integral, like it just makes sense. I can just see it.
It's right here.
So I failed, but that's fine.
Daddy, which one do you want to talk about? 1, 2, or 3 or all?
I got 2. Wait, I got 2, right?
Which 2? Or number 2?
Yeah, number 2.
So number 1 Why is it increasing on negative 2, negative
Okay,
1?
look, like, I know it's positive, but at
Because
the same
f prime is positive, which means that f is increasing.
yeah, I know that it's the derivative, but you say it's increasing, and technically it's increasing if it's the regular, but I was thinking increasing as in, like, you know, like when you do the sine line graph and then it goes
Well, right, that's
and
actually
it's
why you have to do a sine line graph. So check this out. I'm going to do a sine line graph for f prime, okay? F prime is 0 at negative 1 and 1.
Yeah.
If I do a test point
Oh,
of
it's still
negative
positive.
negative positive, then
Okay,
it
never
goes
mind, I'm
like
done.
this.
Okay, what about 3?
Okay, so let's do a graph for the second degree.
Oh,
The
yeah.
slope is 0 at
Yeah,
0.
I got that
Negative
part.
slope, positive slope. Concave
And if
down, concave up. Is it concave up? Negative
Oh,
1 to 0?
no.
No, it's concave down.
okay, that makes sense. Thank you. I'm good now, Miss Mitchell. Thank you.
I'm not supposed to be scared.
I hope that if there's one more problem with that, I can actually get it right.
It's the orange peel. He's so good.
Guys, number 20 is a thinking question.
They're all three questions.
Nah, some of them are just mathing questions.
You still have to think to do the math.
Oh, Isaac, I was just going to give you an orange. Isaac!
You got it. Woo.
Guys,
So
okay. Guys, listen. Okay. When they give you a question like this, they're almost always testing a theorem. They're usually testing intermediate value theorem or mean value theorem, usually. Right? Do you guys think? Is that my phone? It's probably one of my kids. They're fine.
they're fine.
What if it's an emergency?
It's giant.
Can I answer it?
Can I stop right here? You can answer it. Yeah, it's my 10-year-old. Tell him mommy will be home in 15 minutes.
No, you won't. That's what our class ends.
I know, but at least I'll give you 15 minutes. Hey, guys,
Yesterday?
does the fact
I gave money at work.
Yeah, but you had to actually
Oh, yeah, I
work
got
to
a
get
raise
it.
today.
Hey,
I
guys.
just gotta rely on Henry and get my $25.
guys, listen up. He said okay. When I have a table and you see how it's like going up, does that mean it has to be increasing on that interval?
It probably would have come. Because my phone was almost over.
Really? Because what if this graph looks like this? What if it looks like that? Raina, right?
Okay.
What if it looks like that?
Of course, Henry.
Increase, 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 increase.
It doesn't because I graphed it. But it's still
How can you graph it? You only know points.
X and Y?
You have a point and a point and a point. What makes you think that it has to go like that?
Well, actually, you're right.
What if it goes like that?
I don't like that. Stop.
But can it?
It goes.
Okay, so that does not have to be true.
Well, I thought it was true too.
Nope. All right.
It's false?
False.
Oh, but it's closed interval, so it doesn't actually go.
Okay. In between 3 and 5, does it have to be concave down? 3, 5,
Not
4,
necessarily.
3, 5, negative 2. Does it have to be like that?
No.
No, because Rena, what if it was like this? You always have to think about these crazy graphs. Guys, did we not just look at like some crazy graphs that don't behave the way we expect them to? No, this was the one we did, Zach. It was e to the x
Crazy.
sine of x squared.
That's pretty cool.
Now, so let's say I tell you there's a point here and here and here. Is it increasing? No, it's going like that. You know what I mean? Don't read too much into it. Follow. Okay. Guys,
That was a Parker's dream. What is this?
Right now, does the minimum value have to be negative 2? Right now, what do you think?
Maybe or what?
Does the minimum value have to be negative 2?
No.
What if it goes like that?
And couldn't it? Oh wait.
What goes like that?
That's crazy.
Right? Okay. But let's think about this. Hey, guys, listen, this is kind of important, okay? Whenever it says f of c, you're almost always using IVT. When it says f prime of c, you're almost always using MVT. Okay. Guys, listen. Can I show you something real quick on here? Guys. I'm going to teach you how IVT works, and then I'm going to teach you how MVT works. This is IVT because it says f of c equals 0. It has to equal 0 between here and here. Okay, guys? Because it has to cross the axis because it's continuous. Do you guys understand that? Abby, you understand that? Did I lose you guys? Should we end? We can end. Raise your hand if you're still listening. Okay, fine. No, you're not.
I don't know what's happening.
No, let's just go home. I'm trying to teach you guys something.
I'm not even distracting you.
That's minus 10 points for you, Isaac.
Abby threw an orange.
I just distracted you.
Okay.
That's why.
Guys, remember that I'm not paid to be here. In fact, I'm giving up 2 hours of my afternoon to come be here.
Okay.
Okay, do you want me to teach you the difference between IVT or MVT?
Yes.
Okay, then shut up. All right. Is there a 0 somewhere between there and there? Right now. Stop. That's IVT because it's talking about f of c and it's saying between negative 3 and negative 2 there has to be a 0. Okay.
It's true.
That's the true one. Look, if this had an f prime, it's also true, and I want to show you why. Okay? Because I've seen questions like that. If it has an f prime, it's talking about the slope. So it's talking about MVT. Now here's what you do. What can you guys tell me about the slope between those 2 points?
Negative.
Well, it's the same.
Between 1 and 4, what is the slope equal? y2 minus y1 over x2 minus x1.
Which is
Right?
Yeah, it's 0.
By MVT, there is a point where the derivative equals 0 between 1 and 4. That's MVT. So it's MVT, which is what I thought this was originally, because that's usually how they test these, is you have to find somewhere in here where the slope is 0, and then say, okay, the derivative would have to equal 0. Okay? But this one wasn't that. This one was IVT because it didn't have a derivative, so you just have to find where it crosses 0.
What's the one for derivative?
So,
There's not one.
the way that I would intuitively prove that is saying that from 1 to 2 at some point the slope is positive, and at 3 to 4 at some point the slope is negative. And if the
Yeah, so I have to go, it has to hit 0.
at some
Right.
point.
But I'm just saying, all you have to say is MVT.
Would they accept that answer though? For your response? It's not exactly by MVT.
At
but
some
it
point-
kind of is.
If it says continuous and differentiable, you should be okay. Be careful, because if it doesn't say differentiable, we have like issues like that. And then that doesn't have to be. Like this one does not pass MVT. But if it says continuous differentiable, you can. Okay, we good?
Wait a minute. So the reason why D is correct.
It's because between 4 and 5, it has
does,
to
yeah.
cross the axis.
Wait, but what about? And that's using intermediate value theorem. And the
That's
difference
using
between
intermediate value.
the difference between mean value theorem and intermediate value theorem.
Mean value theorem asks you about the slope. So mean value theorem would say, does the slope have to be 0? And it's yes, because the slope is 0 between this point and that point. Those are the 2 types of MVT and IVT that come up. Okay?
And intermediate value theorem is just like it has to pass through.
It passes through. That's
Okay.
exactly right. Okay. On. Let's look at my sheets here.
Oh, Miss Mitchell, I'm gonna have you for all 3 years. It's gonna be great.
That's so exciting.
I know, because I'm taking AP.
They never put me in there.
You have to go get a slip.
I did, and
Oh.
you signed it.
Yeah, they're fine.
Like,
I'll
I'm in
go
their
there.
spreadsheet, but they never changed it on Saturday.
They're probably gonna do it later. Guys, I have to cancel next Wednesday because of student council interviews. So what? We just did this. There is no session on Saturday. I'm taking Saturday off.
Hurry up.
And next week it's Monday, Saturday, and Saturday is BC only. Okay?
Wait a minute. Wait.
Monday we're gonna do Unit 6. It's gonna be major.
Well, I can't
Wait, so
call
I can't be there.
Why not?
because I have tennis
Or
practice.
every Monday, I have to see the Monday session.
So the
Just make sure you get work off on April 8th and April 29th for our full practice AP test.
Full practice AP.
We'll be sitting in here for 3 hours taking a practice AP test, yes.
April 8th,
Oh,
and April what?
April 8th and April 29th.
That's okay, I don't work Saturdays. I work Monday.
We're gonna take a full practice test, which I'm gonna grade and tell you if you got a 1, 2, 3, 4, or 5.
Okay.
Oh.
29th, I don't.
On the 8th, or whatever, on the first one, we'll all take an AP test probably. And then on the second one, the AP people will take AP and the PC. Just speak out.
Line dancing.
More accurate of testing conditions. All right. Hey, look around your immediate person. If there's any trash on the floor, will you pick it up, please? Or any fruit snacks that Isaac threw? Or any calculators?
I won't. You need to sing for that.
Why?
It's not a good enough reason, man.
Distract Annika.
Yeah, as literally I was walking around, I was like, I called my mom 3 times, and then finally she came back and was like, did you do any good driving today? And I was like, that wasn't fair, and I'm like, I'm not driving you. And I was like, well,
Westlake.
so, and then I was like, oh, wait a second, the Calc review's going on, I can get an review somebody over there.
Thank you, Mitchell. Do you help me all this stuff? Sure.
Yeah, Mr. Romero.
Wait, you want to talk about
That's on the side, that's
Yeah.
I mean, I'll take it home. I've got to leave it.
That's where I learned my true identity.
Thank you so much.
I don't leave yet.
Anyway, I'm almost done.
Later.
Wait.
What? I know, for next time. Because I have to, pace you guys.
That's not bad.
I thought he goes, okay, cool. Like, he talks to
He actually talks just like
He's 10 years old. I'm not, hopefully not just like you.
he tells dirty jokes, and I'm like, dude, you can't do that.
Like, yeah, I was so little.